In this video, I'll show you how to calculate the implied rate of return or the implied yield on various types of cash flows and various types of investments. So let's begin first off with the easiest one. Consider an investment that costs, say, $1,000 and it promises to pay you $1,500 4 years from now. Reasonable question is what rate of return do you earn on such an investment? Well, on most of these, I'm going to show, actually all of these, I'm going to show you a timeline. That timeline will help you understand where the cash flows are. It'll also help us understand and use the internal rate of return, the IRR function. All right, so in this case, the timeline shows us we're going to spend $1,000 right now. We're going to get $1,500 4 years from now. And the reasonable question is what rate of return does that get you? Is this a good investment? Is it a bad investment? Well, one way of identifying that is to see what the rate of return would be. Well, one way to think about this, back to fundamental principles, is to note that if, and I'm going to highlight the equation right here, if R is a rate of return, then if you take $1,000 and you invest it at a rate of return of R for 4 years, it's going to grow times 1,000 times 1 plus R to the 4th power. This is basic compounding, basic time value of money calculation. Now, if that $1,000 is going to grow to $1,500 over year 4, as this timeline shows, then 1,000 times 1 plus R to the 4th equals 1,500. We can solve this using 7th grade algebra, 8th grade algebra for R. And the solution for that, if you do the algebra to solve it, is R is the 4th root, so raised to the 1/4 power, of 1,500 divided by 1,000. Take this 1,000, put it over here on the right-hand side by dividing 1,500 divided by 1,000. Take the 4th root of both sides. Subtract off 1, and that gives you R. So 1,500 divided by 1,000 raised to the 1/4 power, which is the same thing as the 4th root, minus 1 is an answer. Now, not necessarily the easiest way to get the answer, but it is an answer, and we can actually do the calculation equals. All right, so I'm going to do I'm going to need some parentheses, 1,500 divided by 1,000. There's the final amount divided by the initial amount. We want to raise this to the 1/4 power, so we can either raise it to the 0.25 power or 1 divided by 4. Just be sure you have parentheses in there. And then we want to subtract off 1. Well, do I need more parentheses in order to subtract off 1? Well, no, I don't, because remember your order of operations, exponentiation happens first. All right, that's great. We've got that going here. Multiplying and dividing, that happens second. We've got that within parentheses here, and adding and subtracting is the last thing that happens. And so when we do that, we end up with 0.1067 or 10.67%. Now, perhaps an easier way to, and I'm going to move these over one so that I can show you the formula. Equal formula. That's the formula that I just entered for you. Now, perhaps an easier way to do this that doesn't require any 8th grade algebra is to use the rate function in Excel. Now, the rate function, equal rate, takes those 5 items that go into its time value of money, 4 items that go into its time value of money calculations: the number of periods, the periodic payment, the present value, the future value, and then of course we need to specify whether or not this would be an ordinary annuity or an annuity due. We don't really need a guess most of the time. I'll explain that in just a second. But in this case, what we have is a lump sum at the beginning. That would be a present value. We have a future value, that's 1,500 at the end of year 4. We don't have a periodic payment because we don't have an annuity here. We just have the years 1, 2, 3, 1, 2, and 3 have zeros in there essentially. All right, so the number of periods is 4. Our payment is, well, we need to think about this. Excel is always asking the question, what must I pay in order to get? So in this case, if the cost is $1,000, that means I have to pay $1,000 in order to receive $1,500. So that $1,000 has to be negative in this function. All right, so there's my, oops, and that's not the payment. That's supposed to be 0. Sorry. The payment is 0. The present value is negative $1,000. I have to pay $1,000 in order to get this investment. My future value is a positive amount. That's how much I'm going to receive. I pay $1,000 now. I receive $1,500 4 years from now. And then the type, it doesn't really matter because there's not an annuity, but if you want to stick it in there, you can put 0 in there. And I'll explain this guess in just a second. All right, so you can usually leave off the guess. You can always leave off the guess. And in this case, I get the same answer, 10.67%, and I'll copy the formula text over so you can see what the formula is. Now, let me tell you something about this guess, because it'll show up every time you use rate, and you may actually have to use it sometime. Guess, the way that this rate function works is that it takes these cash flows and it calculates the present value, and it tries different interest rates in order to until the present value of all of the cash flows together is equal to 0. And it uses a search algorithm in order to do that, and it needs to know a place to start. Well, it will always start by default at the answer of 10% and then work its way through there. And for most normal types of problems, that's perfectly fine. But if you have an investment that has a huge negative rate of return, I don't know, negative 150% or something weird like that, or a really, really huge positive rate of return, 1,000,000%, then it may have trouble finding the answer starting at 10%. But we'll assume that, and all of the examples that I have will be easy enough that you don't need to put in a final guess. So we don't need a comma and then whatever this guess might be. But if you were to put in a guess, you could put in a guess of 50% or negative 50% if it wasn't converging. All right, so there is 10.67% for this example. Now let's make it a little bit more complicated. Consider an investment that again costs about $1,000, and in this case it's going to promise to pay you $500 a year for 4 years. So instead of paying you a lump sum of $1,500 at the end of 4 years, this investment is going to pay you an annuity, $500 a year for 4 years. What rate of return do you earn, or what's the yield on this investment? Well, there are two ways to work this problem. I'm going to do the first one the way that we did this initial problem, which is to use the rate function. I'm going to do it again. And then I'm also going to use another function called the internal rate of return, the IRR function, which sometimes is easier to use, sometimes not. In order to use IRR, you have to actually create a timeline. And I've done so, but you don't always want to have to go through that step. But let's use the rate function first. The rate function, all right, in this case, our number of periods again is 4. Now, in this case, we don't have a future value. We only have a series of payments. And our series of payments is $500. And so we're going to receive $500. They should be positive. Our present value is $1,000, but it has to be negative. So I'm going to put a negative sign in front of it. The present value has to be negative. And there's our present value of negative $1,000, because that's how much we have to pay in order to receive the investment. My future value is 0. Now, notice you've got $500 here at the end of year 4. Well, this annuity that's a 4-year annuity of $500 a year includes all 4 of these $500 payments. There is no terminal payment at the end, which would be the future value. So there is none of those. Now, we do need to know whether or not these cash flows are occurring at the end of the year or the beginning of the year. I didn't really make it completely clear on that, but these cash flows are occurring at the end of every year in this example. And we don't really need a guess. We won't need a guess on any of these examples. And so we've got 0 future value, 0 future value, and this is an annuity, ordinary annuity. And that gives us a rate of return, a big rate of return of 34.9%. Now, There is another formula that's also useful for calculating these rates of return, and it'll give us the same answer, I hope, and that's called the internal rate of return function. And I'm not going to explain in this video what internal rate of return means, other than if you have a series of cash flows, this function, this number, IRR, internal rate of return, is defined to be the rate of return that is going on inside of that investment. And so let's do the calculation. IRR. And the way that this works is it's really easy. What you have to do is enter all of the values. You need to have values for every year, an initial value that needs to be the correct sign. We spend $1,000 on the front end, and then 500, 500, 500. If you have zeros, then you need to include a zero. So for example, if year 2 there was going to be no cash flow, I can't just leave it out. I have to put a zero in there. If I were to use the IRR function on that first example, I can't just leave these out in years 1, 2, and 3. I'd have to put zeros in years 1, 2, and 3 for this function to work correctly. But all you do is left click on the time zero cash flow, highlight all the way out to the end of your cash flows. So left click and then drag your mouse over so that you've highlighted this whole region. And then right parentheses, and hopefully I'll get the same answer. I did, 34.9%. So there is the rate that you're earning on this pretty darn good investment right here. Now let's consider another one. Let's consider, in this case, it's another investment, but it looks like a bond that costs, say, $1,000, and this bond is going to promise to pay you $60 a year for 4 years, and then it's also going to pay another $1,000 back to you at the end of 4 years as well. Now, this is the way corporate bonds and U.S. government bonds work. They pay an amount, it's really an interest payment, but they pay an amount every year, in this case 60, 60, 60, 60, and then they pay a lump sum at the end of the time period, which is also called the principal amount or the face value. This, you can wait until we talk about this or until you read this in a bond valuation chapter, but these are the terms. But the cash flows look exactly like this, which is 60, 60, 60, 60, and then a final cash flow of 1,000. I've put those together in year 4 in this case so that we can see them on the timeline, but it really does help for you to think about this as being $1,000 and also $60. So think about that as separate pieces. Actually, let's put it 60 up here at the top and then 1,000 at the bottom, because that 60 is part of this annuity, and then the 1,000 is the lump sum. So it's a little easier to think about. Sometimes it's easier to think about this as 2 separate pieces. In any case, let's go ahead and use the rate function, because it makes use of all of the parts to it. The number of periods, again, is 4. The periodic payment now is $60 a year. So 60, 60, 60, 60. I've got it over there. 60, 60, 60. The present value, again, has to be negative. The present value is negative 1,000, so I have to put a negative sign in front of it. And the future value is also 1,000 in this case, but we need to have a separate entry in our input section. The type is 0 because this is an ordinary annuity. Cash flows at the end of the period, because basically almost all examples are ordinary annuities. And I do not need a guess, and when I press enter, I should get 6%. Now, let me show you real quickly what happens if you don't get the sign right on that initial investment. So that's in B38. That's this argument right here. So I've got, it's $1,000 in cell B38. I've got a negative sign in front of it, turning it into a negative number. Suppose I forgot to do that. Suppose I just put a cell reference pointing to B38 and I did not put a negative sign in front of it, so that I now have number of periods 4, payment 60, positive 1,000, and then positive future value. Now, economically, what Excel would be trying to do is to say, what kind of investment will give you $1,000 now, will give you $60 a year for 4 years, and then give you another $1,000 in year 4, and you don't have to pay anything? And the answer is, well, no kind of investment is going to do that, and it's going to give you an error. And the error is because there is no rate of return that would just give you money, and you don't have to you don't ever have to pay anything out. That's what you get from your parents or your grandparents or something like that, but you don't get it from investments. So we need a negative sign in front of the cost to turn this positive $1,000 into a negative $1,000 within the function. Now we can also use the internal rate of return. Well, let me go ahead and give you some formulas here. Sorry. Backing up just a second for the annuity, and you can pause the video if you need to. Here's the formulas for the annuity without a lump sum, and here is the formulas that we just did, which we'll do right here. So we just did this for the lump sum using the rate function. If we use the IRR function, we can just highlight all of the values starting at year 0, making sure that that first cash flow is negative 1,000. Notice the timeline, you have to have the signs correct. And when we do that, I also get, well, I got negative 6%. What did I do wrong? Oh, I had a negative sign in front of there. I don't know where that came from. All right, let's try that again. I've got positive 6% because I have positive, I've got negative $1,000 and then 60, 60, 60, and then the 60 and the $1,000 lumped together. All right, now let's do the same thing with one more kind of cash flows. These would be mixed cash flows. If you have mixed cash flows, you can't use the rate function on this at all. So this isn't going to work at all. We'll just do a strike through on that. Nope, no rate function. You can't do that because negative 1,000, 500, 300, 200, 100, that doesn't have enough structure. The only thing that you can do is use the IRR function. And in this case, the IRR function tells us that this investment that you pay $1,000 to get into it, and then you get 500 and 300 and 200 and 100. That gives you an annual rate of return of 5.19%. And I'll give you the formula there. All right then.